Okay, so we got a whole lot with adding and subtracting fractions. There's some word problems at the end, so I'll probably pop those off to a second video. But first off is just how do we even add fractions when they do have a common denominator? So remember before how I said it's the number of copies of a unit fraction. So if I'm talking about the same unit fraction like eighths and eighths, so if I've got 3/8 from a pizza and 7/8 from another pizza, how much pizza do I have? Well, that's 3 1/8 slices and 7 1/8 slices. So that's 10 1/8 slices. So I have more than a whole pizza. And that's what we do. If the bottoms are the same, we add the tops. Or if we're looking at subtraction, we subtract the tops in order, first minus second. Now on some of these, they started mixing in some negative numbers, but we can still handle that. It's okay. All right. And then on a lot of these, after you combine, you typically have to reduce to lowest terms. Now for me, I give you a question like this. Crunch, 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 calculator, enter, poof, it does it all. That's why I love the calculators. Now you just have to know how to type this in and how to interpret what it gives you. Because some calculators default to a mixed numeral rather than an improper fraction. And unless you're answering a word problem, stick with the improper fraction as much as possible. Word problems, though, like saying it was 11/12 or 11/6 of a mile. It was almost 2 miles because it was 1 5/6. Like, that's what I mean. All right. So 9/4 plus 5/4. So 9 plus 5 is 14. So this is, I need to make it bigger because I write too big. So this becomes 9 plus 5 all over a common 4. And then we actually add the 9 plus 5 to get 14. So we have 14/4. Now remember, with reducing our fractions, it's dividing by a crazy form of 1, essentially. So I want to figure out the common factor between 14 and 4, which I see one of them, 2 for sure, is going to do it. So we start with divide the top and bottom by 2. So on top, that is now 7, and the bottom is now 2. So we get 7/2. That is our reduced final answer. And again, we could convert that to a mixed, and if you're crunching this on the calculator and you got 3 1/2, that is the mixed equivalent of 7/2. But try to find on your fraction the button that'll change it back to an improper, just to be safe. Like, that way you know you can go back and forth between the two. All right, so now we have ninths. So these are all going to add up to be ninths. So I got 3 of them, 8 of them, and 4 of them. So 3 plus 8 is 11, plus 4 is 15 of them. So 15 ninths. And now 15 and 9 are both divisible by 3. So we end up with 5/3, or 1 whole and 2/3. Now, again, if you are viewing this on a small screen, this could look like just lines all strung together, and this is actually negative fraction minus fraction. So I'll zoom in a little more just in case y'all are watching on a small screen. So negative 11/35 minus 10/35. So a couple ways to think about it. For myself in my brain, even if I don't write it, whenever I see subtraction, I always think of adding the opposite. So in my brain, I see this and my brain immediately changes it to, I prefer writing my negatives on the top number so they don't get caught in my fraction bar, because every once in a while that happened to me in the past. So they always get written high. So I always change my subtraction to addition, so that way I didn't have to memorize 2 sets of rules. That drove me nuts when I was in elementary school. I was like, just, meh. Why would you memorize 2 sets of rules? Just memorize the one way to change it to addition, and you only got to remember one rule. So I got negative plus negative, it gets more negative. So I know the result here is going to be negative. So negative 11 plus negative 10 is negative 21. We have negative 21 over 35. Weird numbers. 21 is 3 times 7, and 35 is 5 times 7. So these are divisible by 7. So you can actually write that negative anywhere. Alex won't care. I won't care. I just personally prefer to see it on top, so that way when I'm reading it, the negative's there next to the top number. This would be negative 3/5. And now letters, because why not? Why? That's no. Again, I did not write these. I'm just going through them. All right. So again, negative and minus. Now, one of the ways sometimes I'll notate my add the opposite is like that. Actually, let me change the color because the blue looks kind of like the black, just so it's a little more obvious. So negative 19a over 24m plus negative 7a over 24m. So both the terms on top have a's, so they are like terms. I can combine them. So negative 19a's plus negative 7a's. Negative 19 plus negative 7 is negative 26. But still single a's because we were collecting negative a's here, negative a's here. My a's don't magically become squares. And then the bottom stays the same because that's the size of piece of the fraction. So when we're counting up our slices of pizza, apple pizza, if you will, the size of the pizza doesn't change when I'm collecting them. If they were already the same size, I'm not going to suddenly start cutting them all into smaller pieces. So this bottom is going to stay 24m. Now the A on top, M on the bottom, I have no way to interact those. I don't know what A and M represent, but the fact that I'm using 2 different numbers, I just assume they're different and they're just going to stay in the problem. But the 26 and the 24, that I can play around with. Those are both even. So for sure, we're going to divide them by 2. So this becomes negative 13a's over 12m's. So see the number, the letters, variables in there aren't that bad. It's just a placeholder for I don't know, but sometimes we call them different letters because we know they're different I don't knows. And now 13ths. Why 13ths? Oh, at least they're all the same. Now we've got some mixing going on. So I've got addition and subtraction. This is why I like changing the sign. Add the opposite. So I have negative 27 plus 31 plus negative 43. So you could just go from left to right. You could combine your negatives together first and then add the 31, like it, any which way you want. You could just crunch the 3 numbers on the calculator. So my brain says put the negatives together and then deal with the opposite signs because that's how I handled it when I was younger. So negative 27 and negative 43, that's 30, and then negative 40 would be negative 70. So I've got negative 70 plus 31 over 13. All right, so positive and negative fight. So the positive 31 is going to take out 31 negatives, and they gone, obliterated. So we just have to figure out what the leftovers are when those 31 get taken out. So 9 more would get me to 40, and then 30 more, so 39. But since the 70 was bigger, there was more negative, our result is going to be negative. So negative 39/13. Fun fact. 13 is prime. So if this fraction reduces, it has to reduce by 13s. So we need to see, is 39 divided by 13, does it divide? And it does, in fact. If you look, 13 times 3, 3 times 3, 9, 3 times 10, 30. So this actually ends up being, we could say -3/1, or we can just leave it -3. Like, that's the answer I would type, but it is totally fine to still think of it as -3/1, because any problem with fractions, that's like the first thing we got to shoehorn back in there is that 1. So now I've got a denominator everywhere to start working. There we go. Good Lord, seriously? Okay, this is just mean. Like, even Alex just, I'm very mad at this, I'm sorry. We don't mix M's and N's like this. In fact, I would bet money this is actually a typo, because this set of notes actually did have a fair amount of typos, but I don't have an editable version of it. I'd have to hand type the whole thing in again. But that's what we're going to do first. I'm going to use my little marker in black. Look, it's also an M. Now, if you legit get a problem where you have M's and N's, they don't combine and you just list the two terms. But here, they did not mean that to be an N. That's a typo. All right, so 8M plus -5M plus 7M. So 8M's and 7M's is 15M's plus -5M. So 15 minus 5 is 10M's. 10M's over 11x for our fraction size. And 10 and 11 have nothing in common. M and X have nothing in common. That's all she wrote. We don't reduce that one. It's already lowest terms. All right, so there's our quick down and dirty on fractions with like terms, with like denominators starting out. Now, remember last video I was talking about the equivalent fractions? So now if I can figure out what my common denominator could be, I'm going to use that equivalent fractions work to turn my fractions into larger fractions that then have the same denominator. And then I interact them just the same way we were doing on the first 6 here. So we're just marrying those two procedures into a bigger procedure. All right. So adding and subtracting unlike fractions, identify the lowest common denominator, which is also the least common multiple of the denominators. Very wordy. In my brain, like knowing the fancy terms, make the bottoms the same, talk about the same size pieces so you can mush it all together, or crunch it on the calculator. Someday I will get to rewrite curriculum so we focus on what the numbers mean rather than how to make the numbers crunch. Someday. All right. So 4/7 and 9/14. Not same size pizza. But 7ths can be turned into 14 pretty easily. 14 is 7 times 2. So I just need to take my 4/7 and multiply by 2/2, my crazy form of 1. So I'm going to kind of put that in a little thought bubble over here. So I take 4/7 times 2/2, and I get 8/14. Not if. So that's the first change I'm going to make. Instead of 4/7, I'm going to call this 8/14 now. And to that, I'm going to add 9/14. So now I'm talking about the same size slices of pizza. Got 8 of them and 9 of them. So add it up, count it up, that's 17 of them. So I have 17 14th slices of pizza. So a little bit more than one. And then 17 is prime. 14 is not going to divide into that, so it's done. It doesn't reduce. All right, now we have 8/5 and 1/15, and we're subtracting now. Okay, well, 5 and 15, those are pretty similar. 15 is 3 times 5, so I need to take my 8/5 and multiply by 3/3. So there's a number of ways to write this within your work, as long as you understand what you're writing and you understand it when you go back to look at your writing later. I don't care how you notate it. I've done it all sorts of ways over the years. So a lot of times I'll end up doing this whole times 3 on the top and bottom because I don't want to rewrite the fraction. Yay, laziness, except it gets really cramped and ugly, but I might do it in some other problems. So I'm going to do it now just so you guys can see. So on top, 8 times 3 is 24. 5 times 3 is 15. And then the 1/15 still stays. So 24/15 minus 1/15 is 23/15. And then 23 is prime, so that's done. Now we have -2/11 minus 3. So this will oftentimes like sticker shock, freak people out, like fraction and a whole number. What do I do? So why are you doing this, you silly computer? Okay. So in order to figure out my common denominator, I need to see a denominator on both of them. Now remember earlier when we got that 3, and I said you could think of it as 3/1, same thing here. And again, if it helps, this is adding the opposite. So I have -2/11 plus -3/1. So in order to make it 11ths, I'm going to multiply by 11/11 just on the 3. So we'll have -2/11 plus -33/11. -2 and -33 gets more negative, so it becomes -35/11. And 35 is not a multiple of 11, and 11 is prime, so that is done. Now the silly thing is, if we wrote that as a mixed numeral, it would be -3 and 2/11. All right, 31/45 minus 6/9. Well, 4 plus 5 is 9, so this is a 9 multiple, and it is in fact 5 of them. So that is my crazy form of 1, 5/5. So 31/45. And you can either leave it subtraction or think of it as adding the opposite. Either works. But 6 times 5 is going to be 30/45. So 31 things minus 30 things is 1 thing. And if one of the two is a 1, it don't reduce. So see, not that bad even with different denominators. You just take the extra step of making them look the same. And you could even walk through this using the calculator to help you figure it out. Like you do 45 divided by 9 and get the 5, and then say, okay, 6/9 times 5/5. And if you hit enter on the calculator, it'll tell you it's 6/9 again because the calculator automatically reduces. But you could do top and bottom individually. 6 times 5, 30. 9 times 5, 45. So then you have the 30/45. Then you can subtract the tops and get the 1. So it can be done. All right, I'm going to cut it and split it to the second video.